Hello, welcome back to our lab. Will be our CSCI 352 digital forensics. For today we will talk about the lab related to the stenography. So, what is the stenography? Actually, in the last week lecture, we did like cover about it. So we try to hide the information inside another file. Okay, so here's it. So maybe we including like instruction or substitution. So we will try to replace the bit of the host file with other bit of data. So that's what we're going to do. And in our lab, so we're going to like, we have the original image file, and then we try to hide the image file with another secret file. So that's what we're going to do, okay? So this is your exercise. And in our lab, and what now we're doing is like using the substitution. So we're using most of the time using the called a bitmap. So bitmap will be the file like BPM image file. So even actually other formats can be supported as well. So even if you want to try to use that JPEG, it's okay. So we can do it. So we need to know that in behind we just like try to replace some of the bit like of the host file with other bits. So we're able to abstract the files, like just you change the last two least significant bit. So will be last two bit. Okay. And as you know, because in the bitmap, for it's just like of them within the bitmap, so maybe like n times n pixels, and then every pixels inside will be represented by RGB. So it will be the red, green, and blue. So you know the number representing 0 to 20 to 55, okay, within this range. And sometimes it will represent in the hex format. So it will be like 24-bit RGB, and we have like different hex representation. So like of them representing like using 2 digits hex number to represent those RGB bit rate. And mainly inside in the bitmap, the structure, including like signature, file size, and all these like maybe the header, say bitmap, then it will mainly will look at the X pixels like per meter and then Y pixels per meter. And mainly we'll look at the color space endpoints. So that's how we focus on. So when we calculate, so let's say for the color space endpoint is like 36 bytes, or we kind of like, and also we will check the maybe size of the color table, maybe like 3 bytes to save it. Okay, will be the bitmap core header or bitmap v5 header like this, and then we save it. And all the you will see all and then all in the image data, like within they have a pixel array, they save all the pixel one by one, and then we also add the extra padding, okay, 4 bytes padding to it. So here kind of like the structure like of the bitmap image file, okay. And main idea right here, because we know we try to replace last two silicon bit. So if we have originally, if we have the let's say 10 10 10 and like this, and suppose we are representing like AA, or next one like 9D or F0 like this. If we are replace, that means I substitute, okay, to the last two bit. So you see you're going to change. So after like they break down a secret letter and then they change. If we look at the color of the hex, even you change a little bit like A9, 9C, F0, you will see the color, it didn't really change that much. So that means that when you look at the image file, you didn't able really tell the differences, but we did hide the file inside the image file. Okay, that's what we are doing. And in this lab, we're going to like use a bitmap file and hide a text file. Okay, so we need to use the stack hide. So this the application we need to use. Okay, so this one, you can check it. We need to install it. We're using the Ubuntu, so you can work on your Linux system Ubuntu. So maybe you need to install the VM, just same as what we're doing in this lab. So we use it to hide the data file in the least significant bit of another file. So it can be like BMP, JPEG, the WAV file, audio file, anyway. So also it can support some encryption algorithm. Okay, so we can use, and we can try to, we are going to use two arguments we are going to use. One is called embed, one, and then one is extract. So we are going to use, okay. So in the beginning, we need to prepare the left file, so you need to download. I try to push it to the Git, but I test maybe the size limited. Right now I have a Git and I upload all the files. So if you couldn't download it, then you can try to follow this link, the Git link right here. So at least this one it works. Because I want to give you a shorter link. Actually I already gave you the new one. Because I try to prepare it, but I feel like it have some error, so maybe the size like is limited. So if you have some problem, I try to push it one more time and update it. Replace this file with the underscore, and if it is still not yet working, then you can follow this link. So this one is guaranteed is working. Okay, and you can use the empty file. So suppose if you already, so let me list the file. So this one is the download, and then I can use the empty file sum and to check this file. So you will get the empty file checksum of this file. Okay, and then also, and then the next step, for the lab, you need to create a secret message. Okay, so I give you the example right here. They use echo and then save it to a text file. So you can, either way is okay. So I give you example, say you can use the echo or nano, pseudo nano. So either way is okay. So right here, I already create a secret file. So it's called secret.txt. So if I want to create another one, so I can use the echo and then secret 2.txt. So, and because this one is the file format, so maybe I will create, okay, so here is the message. I create another hidden message like this, and then I'll put. So if I list the file right here, so you will see I have a second secret text file. And after you complete this step, you create the file, and you can check the content if you create successfully secret 2. So at least right here, so I create another hidden message. And this hidden message is what we're going to embed inside the image file. Okay. And as a user, we try to check and validate the user owner group and then the writer. So let's check this file. Okay. Of course, in your exercise, I recommend you can try to use your own image. You can download any JPEG or bitmap and try to encrypt your own message, but you are not required to follow mine. Okay. Because since we don't require to display show it again, so it doesn't matter because we already know. Okay, so right now we will start. Okay, to start to embed file. So as what I say, you need to install our first application, the CSCI. So you can use the sudo apt. So if you don't have it, then it will pop out, ask you to install it. If you do, when you type it, it will pop out all other possible agreements. And then what we're going to use, you will see later, you will see what is the, we'll pass a parameter later, first like embed, extract, and also like embed file, and then we give the embed file's name, also like cover file. And later we have the passphrase, that means the file, the password we're going to use to encrypt it, and then you see some encryption, compression. Okay, so all these will be the embedding options. Okay, and then also we have some extracting option, state of file. So all this you will see later. Okay, and extract file, and we're going to use it in our lab. And let's go back to our lab. Okay, so when we need to embed this file, we can use instead hi, and then we going to embed with the embed file. So what's the embed file? I create this time I use the secret2 text. Okay, and then let me move my cursor so you can see. Okay, I can change the layout like this. Okay, so you can see. Okay, so right now I pass the content, and then let's see which file we're going to cover. Okay, so we will cover this original map, and then I give the passphrase, and this time I give the password will be maybe 4, 5, 6, 7 like this. Okay, so once you receive the message, embedding into that file is done, then that means you're all good. Okay, then let's check the ND5 sum one more time. Okay, so it should be not the same with what you have before. Okay, and of course we can check it, let's say one more time, but I don't have to do it. Okay, and after you complete it, then we are going to extract it. Okay, so we can use the step high one more time, and then take the function extract. And if you see from the extract file, we have a step file, original file, SF, and then underscore text. Okay, and then what is the XF? So will be the extra file. Okay, so it will be the extra file secret. We call it but actually I did once before, so I create the second file. XF, and then I need to give a space. Okay, doc text file. Given a password. So the password I use is 4567. Okay, so right now I already extracted. So let's see the extract file. Okay, 2. So it will be the message. Okay, so this one will be the output message. So they should be matched. Okay, so if you are able to complete all these steps, then you kind of like finish like half of it. And next we would like to get the password. Like right now we try to encrypt with the password 4567. And we need to download several things. Okay, first is the we call the word list. Okay, so you have a word list. It's called the walkthrough. This one, the file size is pretty big. I upload it to because I think my Git account is not support this file, so I couldn't really use it. So I think there's some problem right here. So either you can go to content if you're like able to download it, go to content, download it, or you can use this Git link. Okay, so from HTTPS and then all the way to the database walkthrough. Okay, txt.gz. So this one will be the zip file. Okay, so after you download it, will be right here. So you will see I have the tag.gz is the zip file. In the lab is got gzip, or actually by default Ubuntu they do have a tag, so you can use the command line tag and pass the parameter -ztvf and then with the file name, so it can unzip. Okay, so suppose you will get the text file. So this text file is help us to like to guess the password, like some common password. So the size is pretty big. Okay, so you can like check. You don't have to put it in the same location, so I just put it under the same folder. Okay, so you just need to know how can you get it, and then I will try to using. Okay, here is slightly tricky because the original stack cracker is kind of like depreciate. Okay, so right here you will see I'm using a stack seek. Okay, you're going to install the sudo apt install static for your lab. If you refer to some online exercise, others example, they will use it. Of course, you are feel free to install it. If no, then I recommend you to use the static, but it's the same. Okay, and also I made a screenshot. So if you want to follow, will be right here. So you can use the static and then pass the folder and then with the word list. So we can have and then underscore and then word list. Walk you, yes, text. Okay. So you will see the guest password match of the output, and then also it generates the output because I already have a different type of password. So I have a new one, then let me overwrite it. I already have exit, and then let's cat the output file. Okay, maybe we need to file it. Okay. And if you're able to follow all the steps right here, then you're kind of like able to complete all the steps. Okay. And what you need to do just like follow all these steps and then make a screenshot and install the required application, the software, the tool for us to complete the task. Okay. Pretty easy, straightforward. And if you're able to complete all these steps, then you're done with this lab. And for the next week, I will record the lecture part. If you still have like any difficulty working on your assignments and or previous lab, so feel free to contact me and let me know so we can arrange a time so I can help you to fix it. Okay. So this one you say the last one, they say is with calculate say faster for matching the password. So you can compare. Of course, I feel free to compare both of them. How fast will be the guess of the password? Okay. And if you and then that's it for this lab. Thank you.